discussing about an important question. If we have got a spherical shell that is hollow from inside of uniform density, and we have got a point mass firstly outside that sphere, and in second case it is inside that sphere, we have to calculate what will be the net gravitational force in both the cases. When the point mass is outside the spherical shell, this spherical shell is taken to be a point mass of mass capital M situated at its center. So in that case, whole mass of the sphere is supposed to be concentrated at its center. That means whole mass of the sphere is concentrated at its center. So the distance between this point mass and this point mass, this spherical shell is taken to be a point mass with its whole mass concentrated at its center. Now the gravitational force is easy to calculate. That is, the force of gravitation is G m divided by r square. This small r is the distance between the center of this spherical shell and this point mass. Now the case is when the mass is situated inside the spherical shell, the net gravitational force on that point mass is 0. How? Because in this case, this spherical shell is considered to be made of small parts. When these small parts exert a gravitational force of attraction on that point mass m, the whole gravitational force of attraction is equal to 0. That means when a body, let us consider this mass and let us consider this mass, this is part of the spherical shell. It exerts a force of attraction on this, it exerts an equivalent opposite force of attraction on this. So these two forces get cancelled. When we take the resultant of all forces by the small parts of the sphere on this point mass m, the resultant of all those forces is equal to 0. That means the net force of attraction or the net force of gravitation on that mass m, which is located inside a spherical shell of uniform density, adds up to 0.